Welcome back to yet another episode of Matrickz Tech Talk. Today, I have a very interesting guest, Alexander Much. Alex, welcome to Matrickz Tech Talk virtually.
Hi, thanks for having me.
It's wonderful to have you here. So a little bit about Alex. He has worked for and is still working for Electrobit more than 16 years now. And what I really respect about Alex is he's a mathematician. He worked with cryptography. So Alex, I have enormous respect for mathematicians. I'm really excited about asking you some questions. You've been working in the automotive industry since 16 years. Alex have started his career as a developer all the way to ASPICE assessor, safety. So he has a pretty broad view in the automotive development landscape. And yeah, Alex, why don't you start with telling our audience a little bit about yourself, your passion and your background. What motivated you to go into this career route?
First, it was technology. I think it's still technology today somehow, but today is more working with people and organizations. So when I started, I had a team lead with Steffen Reit. He's now professor in Wiesbaden, and he told me, please do elliptic curve cryptography. Here's an 8-bit controller. And then I asked him, okay, how should I compare times? And he, at that time, he had these big watches. So he gave me his watch and said, you could just press start and stop, and then you know which algorithm is better and faster. And yeah, so it was really technology. Yeah.
So in your long-term experience in automotive industry, I would start with, tell us about some of the challenges you faced. Before we talk about a particular technology, we want to talk about classic AUTOSAR safety and a little bit of adaptive AUTOSAR today. But before we go there, can you share some of your personal experiences where you faced some challenges and you came up with solutions and ideas that would help our audience?
Ooh, that's an interesting question. Sort of the first challenge was good programming, and embedded C or automotive embedded C is not really, let's say, taught at university. If you have a PC, if you have Linux and have a C compiler, you're not experiencing all these kinds of things from 8-bit machines and big and little endian, broken and crappy compilers and linkers, and so there was a lot to learn then. Yeah. So that was when I got interested in making people better. So we got interested in MISRA, and I was also writing a MISRA checker then, which we used for many years. So the first was really programming. So I was really a techie. If you came to my office, you always got a binary answer. You know what I mean?
I love binary answers. Yeah.
I was teaching people how to program, and this is something I still benefit from. It's for me, it's always surprising if I meet let's say a SPICE assessor or a safety assessor, and you ask technical questions, and you realize these people are coming fresh from university, or are only look at documents or things like that. So for me, it really helps also today. If I'm doing a SPICE assessment, I can say, okay, show me the code, and I can. Sometimes I had to say, I don't care about your process. If this is the result, the process got to be bad. So for me, I think it helped a lot to have this basis, to actually be able to get your hands dirty.
I love that, because I agree with you 100% that we have ASPICE assessors. Of course not all of them, but many of the ASPICE assessors who are focusing on the process part and do not usually have deep technical knowledge. And that is a problem. In my opinion, sometimes they have unrealistic expectation, or they are not able to, as you said, assess the project in an objective manner, the way someone would do if they had technical knowledge. And I love the statement you just made. If that's your product, then I don't care about your process. The process does not work. How do you advise companies like ours to go about it? When an ASPICE assessor is only focusing on processes and not having deep understanding, or the other way around, what do you advise usually? What is the right way to go about?
It's complicated. I'm now 46 years old, so I'm feeling, I get a little calmer. But it's this bipolar thinking. So there are people who say, if you favor process over people, you're a kind of Taylorist guy, and then you say if you favor people over process, that's the right way, that's the agile guy, and both are wrong.
Both are wrong.
So to be honest, after many rounds of process improvements and things like that, you come into organizations and you see plans that are as high, thick, so that size, a project plan, and this week, especially requirements tracing and linking, where you say, okay, now I have 25,000 requirements, and you have 70,000 links, and you look at all that and you say, okay, the thing you need or you want to solve in the end is software engineering. And this is a very complicated thing to do. Because, Ted Daughtry from the United States once had a keynote on the EuroSpy, yeah? And he made the thing that he said, people always say it's not about rocket science. And then he tells his students, everything need to know about rocket science, I can tell you in 10 seconds. I pump up a balloon, I give you the balloon, and then you open your finger, balloon goes away. This is what you need to know about rocket science. But putting 1 million liter of explosive things on a ramp and shooting it up into the sky, that's the problem. So it's rocket engineering. And that's the same here. I mean, we are dealing with a highly intellectually complicated thing and a lot of group dynamics. So what I can tell people is, first, you need to be rooted in technology. It's the people. Your quality management is people management. And I know people who think, quality management is filling out Excel sheets and making the Excel sheets happy. I've never seen that actually work. Sorry.
Fascinating. I love that. I love that. With that, since you're talking about people and technology, and deep dive into technology is necessary, and I agree with you 100%. This would be the perfect segue to enter into the discussion that we planned to have today, is about AUTOSAR, classic AUTOSAR safety, and we're going to talk a little bit about what is the delta, what are the challenges in terms of safety in adaptive AUTOSAR as well. So can you please, from your long-term experience, give our audience the idea of the evolution of AUTOSAR Classic and the safety of AUTOSAR Classic? And where do we stand today? Where are the challenges?
AUTOSAR and safety is the point is, I know many people in the business and in the consortium, so I have to be careful not to finger point so AUTOSAR and safety evolved over a long time now. And when we went in serious safety, we always did safety projects. That was just a small part, but when the ISO 262 appeared on the horizon, and also AUTOSAR tried to take it more seriously. And there have been approaches, I think, around 2010, 2011, where people say, just develop all your stack according to ASIL, and that's it. We looked at other domains. So what is avionics doing? What is medical doing? And no one there does it like that. So I can give you an example. Let's say you now have a laptop in front of you, I guess.
Yeah.
I'm Bill Gates. Here is Windows. I have been through some certification authority, let's say in Nigeria. They said it's ASIL D. So please, just use it. So that doesn't work. And so the problem with the middleware is you can either go there and make everything and infect basically everything with ASILs, or you say, no, that's not the case. We need to solve, so in my opinion, safety is solved, or software safety is solved on a software architectural level. And it is not the implementation. So if your life depends on this single line, this if, or this function call, or whatever, you should not use or should not build the system. So from an AUTOSAR perspective, the idea was to, and then other vendors also follow that, the idea was to have as little as possible with ASILs in your software architecture. And that's very classical. If you look at the DO 178C, there's a chapter that basically says that there are only 3 safety mechanisms that you need in software. It's monitoring, it's diverse software, yeah, and it's partitioning.
What is the second one? Monitoring, and the second one is come again?
There are only 3 mechanisms you have in software safety. It's partitioning, monitoring, and dissimilar software, or diverse programming. And that is now the basic discussion point you have with middleware and safety, is people hate partitioning. Because when you do proper partitioning using a memory protection unit, you just waste a lot of time. It's really intensive in computing. And if you go to the avionics people, if you go to Airbus and you gave them an ECU and the load on the ECU is more than 30%, they kill you. Yeah. If you go to the automotive industry, the load is always 100%, because, you know, if they realize that 60% is the load, they're going to source a cheaper chip. Yeah, so the point is, partitioning was always problematic, but from an architectural point of view, it's the only sane way of doing it. So you cannot, even if some certification authorities follow that, but you cannot take 100, 200,000 lines of code with 50,000 parameters and then say, I insert this code and it doesn't affect my application. I strongly distrust these beliefs, because they are not taking into account the system, and the system includes hardware faults. So if I'm saying out of context, this is software, this software is perfect, it's still not perfect when the hardware is not perfect.
Absolutely.
So that was always the balance in AUTOSAR. Now, people who say, it's just, I just take the process, apply the process, and then I'm ACLD, and then I can do whatever we want with AUTOSAR. And I distrust that. I don't think it works.
Absolutely, because that's safety element out of context, and you can only make assumptions, and you have to look at the entire safety from the systems perspective. You talked about 3 points. One was partitioning, one was dissimilar software, the third one was monitoring. Can you tell us a little bit about dissimilar software?
Yeah, so dissimilar software is it was the hype in the 80s or 90s, and it's still very much used in things like satellites, where you have really reliability requirements. So the dissimilar software is basically, you have the same software requirements, but then you start with different design, different implementations. You can use different compilers, different tool chains. You know, it's complicated. So it's just basically having 2 diverse things. And that is an interesting approach, but quite kind of problematic, because first, it's very hard to say which level of dissimilarity you need. So you can always say, you know, take a different linker, take a different compiler, take a different programming language, take a different team. Maybe you take a different team culturally, you know, an Indian team or Romanian team or whatever. So it's hard to prove when you also to argument when you have enough dissimilarity. The second one was, I mean, I'm sure you're familiar with Nancy Lewison from MIT. So she made a paper in the 80s where they gave different American, I think, 17 universities in the United States the same programming task to a simple flight control system. And they said, okay, let's have them all write differently and see if they make common cause errors. Because regardless of what you do, the common cause error is always in the requirements, or it's in a certain interpretation. And 7 of them made the same programming error, assumption in programming. Yeah? And for me as a mathematician, that's kind of hard. So they said the cosine of 0 is 0. So 7 of them made the same error. So that somehow proved that dissimilar is very hard. Yeah? So one of these stamp meetings, there was a chief engineer of Boeing, and he stood up and told Nancy that in all the time that Airbus, that Boeing developed planes, that was before MCAS and 737 MAX, so it was 5 years ago maybe, he said they never had a software error. So every time they got a software problem, they could trace it back to the requirements. So that's wonderful engineering over there. So the problem with less dissimilar software is you still have the same requirements, and we're back in the corner where we say, how do I express requirements? How do I make them non-contradictory and all these kinds of things? So basically, I think the safety is not in the implementation at all. So the Boeing chief designer is right in that aspect. Fascinating.
So 7 of the students come up with the same error, and that was cosine of 0, 0. It's fascinating to hear that. And you're saying that Boeing is claiming that they had no software error. I understand what you're saying, that safety is not in the implementation, but allow me to stay within the implementation, the premise you set, for a while and ask you some follow-up questions. Now, I'll share an experience with you. So one of our clients, usually our clients come to us for safety consultancy a bit too late in the project phase. So when they face that it's not going anywhere, they come to us. So they came up with the redundancy, like, dissimilar software redundancy idea, that they will create in one of the microprocessor, they will run code based on C. In the other microprocessor, they will run the code based on MATLAB model based. They're using the same compiler, same environment. So I personally didn't see much of a dissimilarity there. I mean, there were more to that story. They were actually sending this frames in the same LIN. There was only one LIN. There was also not redundancy in the hardware, but I'm not getting to that level of detail. As you mentioned, 7 programmers made the same mistakes, and there is no diversity. How do we deal with this problem? So when our clients come and we don't see that enough diversity, what would you advise a pragmatic way to deal with such thing?
But you see, you're in the thing I mentioned. How much dissimilarity is already enough? Yeah? It depends on what is your enemy. So if if you're in avionics, do flight computers, or if you're in the automation industry basically has a very pragmatic approach. Their ASILs or their SILs are not that high. So basically what they're doing is they're going right around the corner to the next supermarket, source 3 super cheap computers. So no ASILs, no whatever fancy engineering there. Then they take their code base, put them through coded processing, put them on the 3 computers, and let some fancy machine vote between them. And that works perfectly. Why? Because their enemy are sporadic hardware faults. And it's very unlikely that 3 computers are hit by the same sporadic hardware fault at the same time. So there, it makes perfect sense. When you come to the logic, let's say an area where we really have problems is ADAS systems. So for an ADAS system, you don't do that multiple times. You can have fallback computers, you can have plausibility checks, yeah, but basically all the things are on the logic. Let's say you have a radar system, yeah, and if you ever looked at radar systems are utterly complex. So the data you get is really crap and a lot of data. So if you have, let's say, a bit flip in your radar data, and this bit flip causes your system to panic or, doesn't make a lot of sense. So what is problematic in one system where you have a bit flip and the logic is changed, you make a decision, yeah, is not problematic in an ADAS system. In an ADAS system, you are on a logical level. So am I allowed to drive here? Is that free space? How do I interpret this thing? Is this a pedestrian or a cyclist or not? So the problems are really different depending on which systems you've built. So what we can learn from other systems. Let's say we have a flight computer, yeah? And this flight computer, apart from redundancy in hardware, has a monitoring system. And the central flight computer usually tells the monitoring unit, hi, I'm the central computer, I'm now going to do something, and within 15 seconds, within 30 seconds, I think I'm flying there with that speed at that height. Yeah, and if the computer does something and it goes out of line with reality, the monitoring system finds that and shuts it off, corrects something, manual control, whatever. So people are good at these safety things if they're good at thinking in control hierarchies. that is what many system engineers can do, but many projects, as you said, in automotive, but especially when they're coming late, they don't want to do that. Have this additional monitoring level one step above. And sometimes it's really easy. An ADAS system is super complicated because the second path is super expensive, and two implementations will never agree if this is a pedestrian or not, or often not agree. Yeah. But if you, let's say, you have a temperature sensor and you are the safety system and you rely on the temperature sensor and you get a temperature value, and the value is 17 degrees, 18 degrees, 1000 degrees, 16 degrees. So what you do? 1000 degrees? No, you just discard it. And these things are done already in cars quite frequently. So there, this monitor above is just an acceptance value test. So it really depends on what you're building. There is no simple answer, and that's why you need experienced people.
Absolutely. It really depends on what you are doing. You have to look at the entire system and the complexity, and you have mentioned a very important and very, very crucial point, which is who's your enemy? What is causing most of the faults? With that, you mentioned ADAS. ADAS will bring new kinds of safety challenges, no doubt about it. And of course, we have SOTIV. Yeah, we'll move to scenario-based testing. We probably will touch that a little bit later today. Let me ask you, like you said, the monitoring system. So that's the perfect segue to ask you your opinion about adaptive AUTOSAR. So we're talking about a health monitoring system in the adaptive AUTOSAR. What do you think it is, like the safety, translating the safety that we can implement in a classic AUTOSAR? We often face a lot of challenge in the adaptive AUTOSAR domain, and also the thing that you mentioned, safety element out of context, having it certified up to a certain ASIL means nothing in the actual context. How is adaptive AUTOSAR going to help, or what are the challenges we have in adaptive AUTOSAR in this context?
First, something about certifications, because that's an interesting point. So the safety element out of context is really a complicated thing. And in other domains, let's say you take the medical domain, you know what it's called there?
What is it called there?
SOUP.
What does that mean?
Software of unknown provenance. So it's seriously, it's called SOUP. And that's really cool, because if you go and see what companies are doing, there's actually an article about the use, misuse, and abuse of SIL levels, which I recommend. You can just Google it. It's important. And the fun thing is that you have some certification authorities and some of our competitors. They go there and they certify certain things, like just the process. Good process does not mean good output. That is simple. Yeah, no one will say that. And but you don't get, if you only have the certificate, you don't know what they certified. So we went with a certification company many years ago, and they, on their certificate, you have the front page, and the front page reads, this has been certified ASIL or SIL 3 or coding, whatever. Huh? But then it has a back page, and the back page is the most important, because that says, and this functionality is actually in the product. So I've seen things where you buy an operating system, you get a certificate, and you know what they did? They certified only the generator, the code generator, but not the operating system at all. So certification is I think certification is a good thing if it's regulated by the government, like in other industries, but it's very complicated if you leave it to the free market. But okay, sorry, you talked about adaptive AUTOSAR. So if you take the safety issues from classic, the approaches are pretty similar. You have freedom from interference approaches, you have monitoring, time monitoring, and so that are established things, safety monitors that are used now decades. There's no real fancy new safety technology in classic AUTOSAR. It's just the application is new. In adaptive, it's more complicated, because it's the systems you let adaptive run on. So basically, to be blunt, I mean, adaptive runs on things like mobile phones. So yeah, from a technology thing. And these systems are way more complicated and way more complex. But from my point of view, very hard to do safety properly in these environments, because traditionally, let's say you have an Infineon RX processor or an NXP S32, whatever, you really have a small processor. You have the RAM is inside. They have safety mechanisms on the flash, and so there it's really easy to do things. If you take a performance SoC, you have a graphic card, you have multiple Ethernet controllers with DMA, you have network accelerators, you have some, we've done systems where you have one SoC. If you look at it, it's just one chip, yeah. But there are 20 operating systems running on it from us, 20 in one chip. You have it for the trust zone, then you have a security controller, you have a safety controller on it, and then this is really interesting. So safety, from my point of view, it is always a system property. It has nothing to do, adaptive AUTOSAR, it's software. Yeah, I put it on a USB stick. I put the USB stick on your desk. It doesn't kill you. But these systems are really complicated, and I think you need to understand the classic world in order to do the adaptive world. If you didn't master a classic chip, you cannot do software safety properly on these performance SoCs. First, it's very hard to get hardware that is certified, whatever that means in detail. So we always try to, like security, we have a trusted anchor. Yeah, we have the root of trust. So basically, we usually try to monitor the performance SoCs with classic ECUs. And many of these performance SoCs have this safety island right next to it. Yeah, so at least control flow, time monitoring, all these sophisticated watchdog approaches are usually done on a classic chip, and there we know how to do safety, we know how to certify it, and our customers are also able to do that. Yeah. So adaptive itself.
So adaptive itself is not going to solve the problem. Would you recommend a hybrid approach?
It depends on the system. So we are part of, for example, the ELISA project. So we are trying, together with OEMs and certification authorities, to bring Linux into safety critical systems. So yeah, we're trying to do that, but it's not.
What is the project called again?
ELISA.
It's
with the Linux Foundation. So you can just Google the project. So that's public.
Yeah, I'm going to put the link in the description of the video so that anybody's interested can go and have a look. Yeah.
But that doesn't mean you take a computer, put Linux on it, and then control an airplane, and not using any additional techniques or whatever. Yeah. So that's really complicated discussion. I think we as an automotive industry need to learn to master that, because if you look at laptops, there is no Dell Linux and no IBM Linux or Lenovo Linux, yeah? And there will be no Volkswagen Linux or BMW Linux. Yeah? It doesn't work like that. Yeah. So this is a common effort. There's from my point of view, there is no competition there. There's no distinguishing thing like I'm an OEM and I make an advert and say I'm killing 10,000 people less than that OEM. So.
Fascinating. I think I'm going to quote you on that. Let's move on to ADAS a little more, because this is adaptive AUTOSAR, ADAS, and the safety is going to be much more complex in the whole domain. As you said, safety is not on the implementation level. I understand what you mean. Being MISTRA compliant is not necessarily safe, but I understand what you're saying. Now, SOTIF, like ADAS, this kind of application takes safety beyond the vehicle. So we have the environment. We're taking a lot of input from the environment. So safety of the intended functionality, right? There is a big unknown. So can you tell me your opinion about the challenges SOTIF and ADAS, the domain of ADAS, will bring, that it's not only failure, but the intent of the functionality matters? And what's your opinion on that?
it's somehow, I think it's Pandora's box, because people are trying to prove that a software intensive system does what they think it should do. And this has never worked. So to be honest, I mean, you can go through all the verification and validation steps of these systems, and then really it is not fit for purpose somehow. And Airbus is doing that. So, you know, they build an airplane, put it in Toulouse, put it on the airfield, and then make real people and have test flights. And they realize, oh, this we haven't thought about that, and we haven't here and there. Traditionally, you took a system in the automotive industry, then you went on the road, you drove for 1 million kilometers, and then say, okay, it works. But you can't do that with ADAS now, and this is the problem with these systems. So the safety of the intended functionality, I've been not at the core of the discussions at all. So basically, what you try to do is you try to formalize this 1 million kilometer approach somehow. If you drive too much, you encountered all the unknown things. That's that's basically the argument, right?
Absolutely. But what is that number? Definitely 1 million mile in ADAS is not enough. Some companies talked about 10 trillion miles. Some companies talked about 7 trillion miles. We're talking about data of trillion miles. And obviously, we won't be able to do it with real driving. And it's not only also the number of miles, it's the test vector. Yeah, one thing we're located in Unterschleißheim, north of Munich. We see BMW autonomous vehicle testing around. One thing it is to drive in the nice suburb of Unterschleißheim, and another thing is to really cover those critical scenarios that could go wrong. And that is, in my opinion, just not possible with real driving, and we have to move towards simulation. I mean, that brings me to another topic, because you really have an interesting point of view. Your opinion on that do you think we will have enough data to really say that it is safe, and how will it be handled? Because the simulation world in automotive is also not as reliable as other industry. We're depending on game engines. So what do you think is going to be the solution to really have a data that you can rely on to say it's safe or sufficiently safe?
You cannot define what sufficiently safe means. You cannot say which data is reliable or is not reliable. If you take artificial intelligence systems and feed them more data, the quality of them can get actually worse. So, no, it will get actually worse. So it's not about having enough data. Let's say we go back and see how people did it in other areas, okay? So we in automotive always, especially in Germany, tend to think, oh, we are the big guys, and, you know, if we go to government, but we're not. We're definitely not in software-intensive systems. Other companies are way bigger, and so we need to look at how did others did it. Yeah? And if you look at these domains from cybernetics, there is a law from Ross Ashby, and it says only variety absorbs variety. And that is one of the few, let's say, really natural laws that of cybernetics. So the idea is you have a system and you have a controller of the system. And the controller of the system needs to have at least as much states as the system the controller controls. So what is the thing? The thing is that you either put more intelligence into the control system, or you simplify the system you're controlling. And all the other domains are very simple. They simplified the system that they're controlling. So you have trains. Trains are in segments. You know, you have a lane, train, empty, and things like that. So you can formally simulate it with Petri-nets and other techniques. If you have the airspace, it's also segmented. It's not like they can fly there everywhere. No, it's really have this lines. This goes to the states, below goes back, and they radically simplified the environment. Mm-hmm. So if you look at an airplane, you know, if a computer has a problem in an airplane, how long it takes for the airplane to react. You have ample time, unless you're landing and there's special, but usually, you have a lot of time to react. If you drive in a car 200 kilometers an hour and your steering goes crazy, you have nothing. So To be honest, if you come from a technology point of view, you are forgetting that technology never wins. It's always the human sciences, the arts that win, and the society. Yeah? So we have accepted models where machines are placed in public, and that is not regulate. It's also regulating technology, yes, but primarily regulating space and freedom. This is why I think an automotive OEM is not responsible for autonomous driving at all. It's not their job, it's society's job. Let's make an example. If you take your 5-year-old kid and put it onto a high-speed train line, you just put it there. Train comes, kid dead. Who's responsible? You are. So there we accept it. We accept it on motorways. Also Autobahn, yeah. The real question is, I can do autonomous driving in Munich right now today. It's absolutely not a problem. You have the streets, you have your paved ways, and then you make plexiglass walls, and then you have a crossing, and you have cameras, and doors open like in a subway, and then you monitor all the people, and then people's doors closed, and then you can drive. It's not a problem. So the question is it my understanding of freedom to be able to cross the street wherever I want? Is it my understanding of freedom that my 5-year-old son is able to play football outside of the house on the street? And if we say we can say no, this is then autonomous cars are there. It is a physical law. The law of Ashby is it's a natural law. So they cannot make a super complex reality and then try to have a controller for it. It's physics. It's not possible. So we need to really focus on the interplay between society, space we regulate, and then the cars we need to build. But that's a personal answer. We're also doing ADAS things, so it's probably not helping sales. But you also see this AI winter and this autonomous driving winter is now coming heavily, and so if you ask me, there will be no autonomous cars in the sense that it is used today, like just throw them in this doesn't work.
Absolutely, I agree with you there. In my opinion, that will come in several generations. The first generation will be not very different from a train when you have an autonomous lane, probably a geo-fenced environment for your autonomous car to be driven. But I really like your point of view that it is a question of the acceptance of freedom from the society. It is not a technical problem. I love that. With that, I'm going to ask you a question that I pretty much ask all of my guests. We're at a dawn of an era where we're seeing unprecedented disruption in the automotive industry. We talked a great deal about one of them, which is autonomous vehicle. In my opinion, there are two more. One is connectivity, connected vehicle. We're going to see massive connectivity. We'll be connected to not only our backend, but also vehicle to vehicle, vehicle to infrastructure, vehicle to X, what have you. And finally, electrification of vehicle. In your opinion, what is the most positive thing that you anticipate due to such disruption that we are facing in automotive industry? What positive thing for civilization? Because I think at least autonomous vehicle is going to be one big change in civilization. It's going to change how we live, how we commute, and how we work. What kind of positive impact it's going to bring for the society?
Ooh, it's a complicated question. So, I mean, electrification is an important thing for the environment in the end. I'm not so sure which technology wins. My wife is professor for that, so batteries and fuel cells, and so that's complicated. And people like binary answers, but those are probably wrong. So there will be a mix of fuel cells and other. So it really helps. So if you look at a combustion engine from a point of chemical engineering, and you just see what goes in, what goes out, and then you see, combustion is just not an efficient process. That's it. I mean, just look at which molecules and stuff. It just isn't. So if we can change that's fine. But it's also a societal thing. It's much bigger. So it doesn't matter if you put the most efficient engine in the car. It's how the power is made, how the power is distributed. How often do people charge? No, I have an electric car now, and a hybrid, sorry, a plug-in hybrid. And I have seen people who get the plug-in hybrid for the tax deduction in Germany and never charge it. So, it's bigger than just putting technology there. About autonomous driving, I'm not so sure. I mean, if you want autonomous driving, just put the car on rails, connect them, you have a train. I mean, just flexible trains. To be a little provocative. So what we're now seeing in the COVID times is that the change in behavior of people, not commuting at all, is much bigger than that. So it comes to connected, and that's a very interesting thing, because I think we all agree is that the transition to the digital world happens only once. So if you look at the differences, let's say you take your grandmother or grandfather. Yeah? So the most fundamental change is not the technology is used. I'm sitting here in a chair. My father sat in a chair. Yeah? We're eating the same food. So that's not. So if you look at the times of biggest change, because people like this word disruption, and in many points, I think it's not an intelligent word. It doesn't describe what's happening, and it's just, if you go to connected conferences, I can't stand this PowerPoint bullshit. So if you look at the changes in society and technology, so between 1870 and 1970, you had the biggest change ever in the way we work, the productivity curves going up. And then there's an interesting saying by the economic folks that says, since 1970, you see the computer everywhere, but not in the productivity statistics. And that's true. There's only a slight, dip at the beginning of the 80s. And since then, you don't see it. And that is because we are not measuring that. We're not measuring this immaterial progress that we have when we type in Google Maps, because, there is no GDP produced when I'm looking up something there. So this is what happens outside of the car. The question, what does it have to do within the car? So if people talk about over-the-air updates, sure, we need some form of update. But to be honest, when I go to my car in the morning, I put it on, and then I have a nice voice that tells me, "Hi, I'm Erica, your left brake. Please give me another 5 minutes. I need to dress up for the new software version. Please wait." I say, okay, fuck you. So there are so many different aspects that you can have with this connected thing. And I think people need to understand that there are different forms. So car is an IoT device, so very limited. Yeah. So there's also an internet of behavior, and that is in your phone. How many cars are there produced per year per manufacturer? And how many Android phones are there? So the car is an Internet of thing. And I think the logic of the Internet of Things is that you deal with the thing first. So what do we get, which is absolutely clear, is predictive diagnosis. The business model for the Internet of Behavior is advertising. It took those companies 10 years or 5 years to figure that out. So Google had no idea that they're becoming an advertising company. And the business model for the IoT is insurance. It's operations. So how do I get operations cost of a car down? So everything gets commoditized and servitized. So that's the business model of the IoT. And now we need to think, is it a business value if I'm streaming Netflix in my car, if I can just put a tablet there? So I think it is an Internet of Things car, and that makes it really complicated for car companies to come up with viable business models. If you go to these connected things, and the dark secret of these conferences is if you ask them, how do you think you're going to make money with it? They say, in the end, we are going to make money, but we don't know why. So it's really complicated. The mobile device has changed our world, yes. Cloud has changed our world. I think the car is, to a large extent, an IoT device.
I love that. I mean, this is a different point of view, and I love the point of view. So, Alex, thank you so much for being with us. It was a lovely discussion, and I'm sure our audience are going to love it. If you have liked this discussion, agree or disagree, feel free to write, comment in the comment section. If you have liked it, smash the like button and subscribe to our channel. We're going to see you in the next video.